All right, so let's go over our first example for classifying quadrilateral. So we're given a quadrilateral, and we have 4 points, or the vertices of the quadrilateral. Right? The first step is to draw a picture. Now, a picture is already given to us. So we go to the second step, and that's to use the distance formula to find out what are the lengths of the sides. So we need to figure out what is the length of AB. To do that, we use the distance formula. Right? So if you remember, if you look back at your notes, you should be able to find the distance formula. I'll set it up here. So we take a look at A and B, the x. So we take the difference of the x values squared plus the difference of the y values squared. Evaluate this, and step by step, follow your order of operations. Do what's in the parentheses first. So we were going to get, let's see, -8 squared plus 2 squared. And then that gets us 64 plus 4, which is then the square root of 68. I like to label the quadrilateral as I go along. So we know that that side is this distance of square root of 68. Now, I'll go to the opposite side next, so that would be side DC. To figure out side DC then, again, we use the distance formula. And for DC, we're going to do 1, minus -7 squared plus -7 minus -5 squared. And that gets us the square root of 68. So again, mark the quadrilateral. Next, I'm going to figure out the side AD. AD, again, use the distance formula. So we've got -9 minus -7 squared plus 1 minus -5 squared. I'm going to use the calculator quick instead of working out every step, just to save ourselves some time. And we end up with the square root of 40. And so, again, label that side. And we've got then the last side, which is BC. So side BC. Again, use your distance formula. So -1 minus -1 squared plus, oops, got a little typo there. Sorry, -1 minus 1 squared plus -1 minus -7 squared. Okay, so that ends up with, again, square root of 40. Now, you might say, well, this is enough to prove that it's a parallelogram, right? Because, again, we've proven this part, that the opposite sides are equal. Go back and take a look. Opposite sides here are equal. Okay. But we need to disprove whether or not it's a rhombus or a rectangle, just to make sure. So in order to do that, we have to double check to see if the slopes are opposite reciprocals of each other. So now we have to take a look at the slope of AB. So I'll write it over here. Slope of AB. So the slope of AB, if you remember the slope formula again, you have to look back at your notes. The slope of AB, setting it up using the formula, is going to have 1 minus negative 1 over negative 9 minus negative 1. And when we simplify that, that's going to get us 2 over negative 8, which then simplifies to be negative 1/4. You're going to want to repeat that again. I'll draw a line here so that way we kind of split our work. We want to take a look then at the opposite slope. So we want to take a look at what's the slope of CD. Oops. So the slope of CD, and I'll have to scroll back up, try to get our points. CD is going to be negative 7 minus negative 5 over 1 minus negative 7. And you'll see that we've got negative 1/4 then, again, as our slope. So I'll mark them up on our picture. We've got negative 1/4, negative 1/4. So far we have opposite slopes. Now we got to take a look at AD and BC. So AD slope of AD is 1 minus negative 5 over negative 9 minus negative 7, which gets us negative 3 as our slope. And then if we take a look at the slope of BC, we're going to get negative 1 minus negative 7 over negative 1 minus 1, which again gets us negative 3. So I'll mark those slopes. We have to make sure to prove that this isn't a rectangle, or perhaps that it is to see if the adjacent slopes multiply to be negative 1. So taking a look at our picture here, do these two slopes multiply to be negative 1? Not at all. Those do not multiply to be negative 1. And if I take a look at this pair, do those multiply to be negative 1? And you'll see that they don't. And we continue that process with each of the slopes that are adjacent to each other. Keeping track, again, do they multiply to be negative 1? And they don't here. So what that means is that our slopes are not opposite reciprocals. So that immediately takes out, see here, rectangle. We know it's not a rhombus because not all the sides were equal. So if it's not a rhombus or rectangle, it definitely can't be a square. We don't have only one set of equal opposite slopes, so it cannot be a trapezoid. And although we do have two distinct sets of equal sides, those equal sides are not adjacent to each other. So our answer then is parallelogram. So going back to here, quadrilateral ABCD is a parallelogram.